Right, in this video I will talk about proofs. There are two parts to this video. The first part is proofs of the properties of var. All right. Right. So the first property is the normalized property. I hope you remember. Right. Now, the normalized property says that row 0 must be 0. But for var, row is the var function. Okay, at 0 is 0, and which is always true. Because if your random variable is 0, then the var of 0 is always 0. All right, so hence the normalized property is satisfied. The second property we must prove is the translative. Is the translative property. And this, as you may recall, this is the translative property, that we must prove that rho at x plus c, where c is a constant, is equal to this. Now for var, this is the same as saying that now I'm going to assume that x is continuous, absolutely continuous throughout this proofs. So this you can write as this, right? And this is the same as saying so what I'm doing here is I'm taking the fx plus c on both sides. Now the left hand side is clearly equal to p, right? Right? And the right hand side you can write as follows, because this is a CDF of x plus c at this, so which is the same as saying that the probability that x plus c is less than or equal to c. All right. Now the two c's cancel out, so what you have is right, and this is equivalent to p. This, by definition of the CDF, is this, right? So hence we have shown that is p is equal to p, which is always true. All right, hence the translative property holds. All right, so that's number 2. Now the third property we need to prove for var is the monotonic property. Right, number 3. Right, the monotonic property is that if you have two variables, x and y, then x less than equal to y must imply the same for var of x less than equal to var of y. Okay, so but this, if x is less than equal to y, clearly the inverse CDF of x at P must be less than equal to the inverse CDF of y at P for all P. Right? That's true by the definition of inverse CDFs. So hence the var of x must be less than equal to var of y for all P. Hence the property holds. Hence all right, number 4, the fourth property is the positive homogeneity property. Right, which says the following, that rho at Cx is the same as C times rho at x, where C is a constant. Right? Now for var, this is the same as saying that var at Cx is C times var. Okay. Right. Now, assuming that x is a continuous random variable, this you can write as okay. Now in the next line I'm going to take the function of whatever on the left and the right hand side, okay. Now the left hand side is clearly equal to P right. Now I'm going to deal with the right hand side. By definition of the CDF, you can write the right hand side as follows. And the C is a constant, so you can cancel them out, right? So this becomes P equal to the probability that x is less than equal to this. Right? Now this, by definition of a CDF, is the fx of fx inverse of P. So this becomes equivalent to P equal to P, which is always true. So hence we have proved the positive homogeneity property, right? Number 5 is the sub-additive property. Now, I said to you before that for var, the sub-additive property does not hold. But for a proof that this property does not hold, right? For var, please see the course website. All right. So if you look at the course website, which you all know, there is a proof that the value at risk does not satisfy this sub-additivity property. All right, so this is the first part of this video. The second part of the video, I will give you the proofs for expected shortfall. So here we are. So this is where the proofs of the properties for expected shortfall. Okay. Right. So I'll start with number 1, which is the normalized property. Okay. Now we know from the previous proofs, we have already proved that var of 0 is equal to 0, right? So hence the expected shortfall at 0, right, which, assuming that the variables are continuous, as I done before, this is the formula for the expected shortfall. You may recall from the previous video. This is the formula. So this is 1 over p times the integral of 0 dt, which is 0. So hence, we have proved that the expected shortfall at 0 is equal to 0. So hence, all right, that's normal. And the second property I want to prove is the translative. right? It's translative property. So now once again we have proved this property for var. In other words, we know that the var we have proved this result, so we can use this. So this implies that the expected shortfall right. This is by definition. Now in the next line I'm going to use this. Right, this can be simplified to the following. Right, and this guy here is simply the expected shortfall at x plus a constant outside. So hence we have proved the translative property. Right. All right, that's the second. Now the third property is the monotonicity property or monotonic property. All right. Once again, we have proved that if x is less than or equal to y, then var of x is less than or equal to var of y. All right, so I'm going to use this result to prove the same thing for ES. So using this result here implies that the integral of var of x is less than or equal to the integral right, and this implies, now I'm going to divide both sides by p, so this becomes 1 over p right. Now what you have on the left hand side is precisely the expected shortfall of x, and what you have here is the expected shortfall of y. So hence we have proved that the monotonic property holds. Right, that's number 3. Number 4 is the positive homogeneity property. Okay. Once again, we have proved this result for var, so we know that var of c times x is equal to c times var. Okay, so I'm going to use this fact to prove the same thing for ES. Now this implies right. Okay, I'm going to divide both sides by p. Okay, so this will become right. Now what you have here is precisely the expected shortfall of p of c times x at p, and what you have here is c times the expected shortfall of x at p. So hence we have proved that positive homogeneity property holds for ES. So right, finally number 5 is the sub-additivity property. Right, now this property holds for ES, right, for a proof, but the proof is not as straightforward as the ones we have seen. So for a proof, please see the course website. Okay. All right. So the sub-additive properties is satisfied by ES, and there are different ways of proving it. I think if you look at the course website, you will see there are 4 or 5 different ways to prove it. Okay, but for this course, I don't expect you to prove any of these properties. I have given you these proofs just because for your own interest. I don't expect you to, I will not ask you to prove these things in the exams or anything, right? So that's the end of this video, and in the next video I will talk about estimation methods for var and ES, because so far we only talked about formulas and proofs, and they're not going to be useful unless you can estimate the formulas. So in the next video I shall talk about estimation, how we can estimate var and how we can estimate ES.